Lumbering through the Soviet Siberian wasteland is something from the world of tomorrow. A nuclear-powered Arctic land train. Designed by the brightest minds of the Soviet Union on the back of heavy tanks for the eventual fallout nuclear destruction of the world. This monster construct was built as a moving power plant to bring the power of the atom to the remote parts of the empire. With 4 separate compartments that could all individually disconnect and operate separately, and only needing 3 people to do so, it was the practical application of nuclear technology in what might be the smallest form we have ever seen yet. Able to be a mobile power source for emergencies in time of peace, or the energy center for the Soviet army in times of war. But this cutting-edge technology never made it past the prototype, and we never saw the rollout of the TES-3, the self-propelled uranium-fueled machine, or what I've called the Soviet nuclear-powered Arctic land train. The project in today's video actually was built and worked flawlessly. Its humble beginnings began in 1955 when Soviet Minister Yefim Slavsky, the atomic commander-in-chief, was given the challenge of exploiting Antarctic resources and establishing a northern military perimeter of the USSR, kind of like a giant ice wall all around the empire. The issue was that these areas were remote at best and downright hostile to humanity at worst. With frozen seas and monster mountains, there was no chance of running power, building a plant, or even sending large boats with generators, making any mining, forestry, or defense construction nigh impossible. The problem was simply that there was no way to get power there. Well, there was one way. Nuclear power was the new kid on the block, and engineers were excited by the idea of small reactors. Just enough power to operate larger machines to open up coal mines and the like until real power could be established. Thus, the minister met the team at the Leningrad Kirov plant, famous for the KV tanks from World War II, and they got to work developing the world's first portable nuclear reactor. Initially, the design was that of a nuclear train on tracks. Engineers would build a railway line with the atomic train powering the machinery, to do so with either a reactor being a single circuit scheme with gas turbine plant, or a scheme using a steam turbine plant of the locomotive itself, of a steam train. The reason that the nuclear reactor also required a gas turbine or steam turbine was that once it ran out of nuclear fuel, like uranium, the train itself would have to be powered by more conventional means. And this wouldn't be the first time that a nuclear train engine would be proposed. The Americans would do so a few years later. But the point is of the story that the engineers were working on this train and building it and thinking about it when they realized that tanks is what they're good at, so why don't they use them as the basis for their reactors? And so they did. The Soviets had a real practical approach to utilizing technology. Using transportable nuclear reactors was a game changer, and something that unfortunately we haven't seen used since. And if you're Australian, then you know exactly the nuclear debate that we have going on right now in the country, talking about maybe nuclear power in the next 30 years. The Soviets had them in the back of tanks nearly half a century ago. And the lesson here is to actually use game changer technology. Honestly, the logic just made sense. By switching to a tank bed, they could rapidly develop a prototype using the spare parts lying around the factory. This tank no longer had to be used in junction with a railway line, something that came with its own practical and design requirements, and obviously, it would be a heck of a lot cheaper to operate. An experimental heavy tank called the T-10, or better known as the IS-8, was used as the basis for this new vehicle. Due to weight requirements, the chassis was modified with an additional 2 road wheels, and it was slightly wider than the original. All that nuclear technology was certainly not going to be light. So the overall design was split from a single locomotive to 4 separate tracked self-propelled machines. They were functionally arranged as a turbine unit that had the megawatt generator, then the heat exchanger and auxiliary unit that helped pump around all the liquids, then you had the nuclear reactor itself carrying all the uranium, followed by the control unit and where the crew would sleep. It would be called the Mobile Power Plant in Russian, or the shorter TES-3, and it would be the key to Russia's ability to dominate the Siberian landscape. So this is how it would all work once assembled. Working fluid, water in this case, would be pumped by the unit with the heat exchanger to the reactor unit. This would then use uranium to boil the water into steam that would then be pumped to the turbine unit to generate electricity. The crew would work in the fourth control unit to manage all of these systems. The reactor block was equipped with a pressurized water reactor containing 74 highly enriched uranium fuel assemblies that could be spun up to power up to 2 megawatts if required for 250 days, which is quite impressive. Naturally, this nuclear power plant couldn't operate whilst it was moving from site to site, as it would require quite a bit of cabling to get it all going on the ground, so it used standard diesel engines. To provide protection against radiation during operation, an earth shield was constructed around the first 2 self-propelled vehicles at the site of operation. The reactor self-propelled vehicle also had a transportable biological shield, which would allow the teams to carry out assembly and disassembly within a few hours after the reactor was switched off, and also to transport the burnt out core once all the fuel had been used. Additionally, there was an air cooler to keep the reactor cold when it was being transported from site to site. As mentioned before, the TES-3 primary's purpose was a utility to provide mobile power to the Soviet army during times of war and emergency power to communities in distress during times of peace, specifically hospitals and other public service centers should the power grid be disrupted. So it's such a brilliant design, and very clearly the engineers have thought it through. What happened next when they actually tried to build it? The team only took around 5 years to develop the prototype land train. On October 13th, 1961, the day that I'm actually writing this script no less, the reactor was turned on for the first time. The train was sent out into the wilds to test its feasibility and to figure out any issues. They did have a problem with the tracks in the permafrost conditions, and special covers had to be made for them, but the reactor itself and the nuclear power plant worked flawlessly. The TES-3 operated for around 13,000 hours without any accidents, not even getting that radioactive over 2 years of testing. This project caught up a lot of attention, and even the first man of space himself, Yuri Gagarin, went to see the machine. So after 2 years of testing in 1965, the order came through for the reactor to be shut down and the machines to be put into storage. A change in the political climate had seen a move away from funding projects with, well, how do we say this? Humanitarian uses of nuclear power, and a push for more wacky military projects. The mobile nuclear power plant was seen as some as expensive, yet impressive, solution for bringing power to the frontier. Vehicles were mothballed with the experiment regarded as successful, and nuclear fuel was removed from the reactor, with engineers tasked to come up with even bigger portable reactor stations called the TES-7 and the TES-8. Surprisingly, an order came through in the 1980s to actually use the reactor again. A decision was made to send the TES-3 to Kamchatka with the vehicle moving on its own power, but the turbine couldn't be started again, and then the project was finally scrapped. In the end, this was still a highly dangerous method to generate energy, and newer generators and trucks with fuel were a much safer option. For the Russians operating on the frontier, it just seemed simpler and cheaper to bring in oil and burn that instead. The technology wasn't lost, however, and a portable nuclear reactor concept was used on water vessels, such as the nuclear-powered barge built in the 2010s called the Academic Lomonosov. But the spirit of the frontier of nuclear power, both metaphysically and practically, will always lie with the incredible TES-3. Thanks so much for watching today.